Hi students, good morning. Welcome to this video session. I remain Samuel Chukwuemeka as usual. In this video session, we shall continue our discussion on permutations and combinations. I call it a palm and comb. Please, this is the part 2 of the video. It is highly recommended that you begin the part 1, that you view the part 1 prior to this part 2. It is also very important that you view the videos in the playlist in order. The playlist is combinatorics. Is on my website. Combinatorics, that is the playlist for the fundamental counting principle, permutations, and combinations. In this video, we shall determine the number of permutations of items. This is what we just refer to as n factorials. N factorials. The number of permutations of n items is n factorials. We shall also determine the number of permutations of duplicate items. So let's say we have n total items, which is n factorial. If we have a number of duplicates, so it will be a factorial. If we also have b number of duplicates, it will be b factorial, and the rest of them, depending on how many duplicates we have. We shall determine the number of permutations of the total items, taking some items at a time. Superscript n, palm, subscript r. Or in some textbooks, you see that subscript n, palm, subscript r. Or in some textbooks, you see that palm, parentheses, n, comma, r. So this is the permutations of n total items, taking r items at a time. Then we shall determine the number of combinations of the total items, taking some items at a time. This will be n com r. Some textbooks will write it as this also, n com r. Or some textbooks will write it as com n comma r. It means the same thing. And these are the prerequisite videos. Let's do some problems. Question 1. In how many ways can 7 people line up at register 3 in Walmart to check out? So we are looking at a order. This is like orderly arrangement, because if they're gonna line up, that means they are lining up in order. So this is a case of permutation. For the questions that we shall do in this video, we shall first of all say whether it is a case of permutation or combination before we now solve. So because this is based on order of arrangement, this is a case of permutation. It is also a case of a fundamental counting principle. Okay, because one person can line up in 7 ways, 2 people can line up in 6 ways, and the rest of them. So this is just permutation of 7 people. That gives us 7 factorials, which is 5,040 ways. I would like to also show you how you can use the calculator on your machine to solve these problems. I don't think I can do both at the same time. Bring it up here. So we probably would have to present this video in this view so that I can show you how you can use your calculator. I am using a Windows 8 PC desktop. Calculator. Just type in calculator. Usually when you type it in, it might be in this view, standard view. Just click view, change it to scientific view. And we have the factorial here. Yeah, I'm going to show you how to use this to solve problems. Now, I don't know the calculator you're using. You might want to look at the calculators you're using. I know you can use TI to also do this, TI calculators to do these problems. Question 2. Find the number of permutations of the word Samuel. If we look at Samuel, we don't have duplicates of the letters. So, and if we count it, this is 6. So you just do 6 factorial. Gives you 720 ways. Question 3. Find the number of permutations of the word Chukwu Emeka. This is a case of a permutation of duplicates. We call it permutation of duplicate items or permutation of indistinguishable items. Or you can say permutation with repetition. In this case, you have to first of all find the total number of items, the total number of letters. If you count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 factorial. Now let's find the duplicates. C does C has any brother? No. Does C have any brother? No. H, no. U, yeah, we have a U. U has a brother here, so there are 2 duplicates, right? 2 factorial. K has 2 duplicates. You write 2 factorials. W, no. U, we've mentioned it. E has 2 duplicates. That's the 2 factorial. M, no. E, we've mentioned it. K, we've mentioned it. A, no. So that gives you 11 factorials over 2 factorial times 2 factorial times 2 factorial. If you're using your calculator to do this, I want to teach you something in your calculator, and that is the memory function. M plus is when you put something in memory, and if you keep want to adding it, if you want to keep adding to that, you just press M plus. If you want to remove something from it, you press M minus. MS is save memory. MR is memory recall memory. MC is change memory, change the memory. Okay, something like cancel. Okay, cancel the memory or change it. Now, if we want to do this, for example, okay, I'm gonna do 2 factorial times 2 factorial times 2 factorial equal. You must press equal to this 8. Then what am I going to do? I press it M plus. Okay, I put it in memory, and once you press M plus, that means the M comes up, memory. So the next thing I do is I do 11 factorial, then divided by memory recall. I recall the memory, okay, and press equal to. That gives me 4989600. 4,989,600 ways. Okay, it's kind of saves time, you know. Question 4. In how many ways can the digits in the number 345237573 be arranged? This is also a case of permutation of duplicates. So if we look at this, 3 has 3 duplicates, 4 has none, 5 has 2 duplicates, 2 has none, 3 we've used it, 7 has 2 duplicates. So if we are using this calculator again, we want to do this first, okay? We do 3 factorial times 2 factorial times 2 factorial equal to 24. Now, if you press M plus, that means you've messed up everything. Before you continue, just remove this change memory or cancel memory and then put M plus now to save the new memory. Okay, now assuming we are doing additions, if we want to add to what we have saved in the memory, we can still press M plus. Yeah. But if we are starting on a new problem, then we have to first of all remove the memory first. Remove it first, then press M plus to save it again, to save the new memory. Then we do 9 factorials divided by recall memory, which is this 15120. You have some calculators that gives you NCOM arrow, NPAM arrow right away, in which case it is much more easier. Okay. We might have to also demonstrate in class how you can use your TI-84 plus to solve these problems. Okay, question 5. In how many ways, this is ways, in how many ways can 4 people boarding a bus be seated if the bus has 7 vacant seats? Again, this is a case of permutation. If people are boarding a bus, they are seated in order. So this will be 7 palm 4. 7 palm 4. And you do 3 factorials equal to 6. Remove this, M plus. Okay, I think I messed up somewhere. Do 3 factorials. Okay, that gives you 6. Let me clear entries. 3 factorial 6. Okay, you don't need to equal to this 6. Remove memory, M plus. Then you now do 7 factorials. Okay, divided by recall memory equal to this 840 ways. Yeah. Maybe when you don't do any arithmetic function, you don't need to put equal to. Like if you just do 3 factorial equal to 6, you can go ahead and just save it in memory. Then you now do 7 factorial divided by memory recall, 840 ways. 7 palm 4. Okay. Question 6. Slide 8. Question 6. 30 people purchase raffle tickets. 3 winning tickets are selected at random. In how many different ways can the prizes be awarded if the first prize is $5,000, the second prize is $3,000, and the third prize is $1,000? If you look at this question first, okay, we know that it's a case of permutation. Why? Because there is an order here. They specified what the first prize will be, and somebody has to claim the first prize. Somebody has to claim the second prize. Somebody has to claim the third prize. So there is an order here, first, second, third. And in that case is a case of permutation. So what you have to do is 30 palm 3. 30 palm 3. Okay, that's what. Here we are using calculators to do this part 2. In part 1, we shall show our work. You know, I'll show you how to do it step by step. We shall still use calculator, but I'm going to demonstrate it on the board, how you can use the formula step by step to get the answers to this. So if we are doing this, this is 27 factorial. You change memory, put in your new memory, then 30 factorial divided by memory recall gives you 24,360 ways. This is a permutation because we have first prize, second prize, and third prize. Question 7. Question 7 looks like question 6, but I want you to note the difference. 30 people purchase raffle tickets. 3 winning tickets are selected at random. In how many different ways can the prizes be awarded if each prize is $1,000? So in this case, this is a case of combination because it is like not in order. They didn't tell us first prize, second prize, third prize. So this is a case of combination. And if we are going to use the calculator to do it, we first of all do 27 factorials, gives us this, times 3 factorials, okay, equal to this. So I'm going to change memory, put this memory. Then I now do 30 factorials divided by memory recall. Gives me 4,060 ways. Okay. Question 8. In how many different ways can a committee of 12 be chosen from a group of 21 politicians? This is a case of combination. Your 21 come 12. This is just 21 come 12. Okay, it's a case of combination because they didn't specify maybe in how many different ways can maybe a president, a vice president, a secretary be chosen from a group of 21 politicians. They didn't say that. They just say a committee of 12, which could be anybody. Okay, so that's the case of combination. If we have to do this with our calculator here, this is 9 factorials times 12 factorials equal to this. I remove this, put the new memory. Then I do 21 factorials divided by memory recall, and that is 293,930 ways. Comprende? Do you understand it? Question 9. Let's look at question 9. In how many different ways can a committee of 12 be chosen from a group of 16 Republicans and 5 Democrats? Okay, if you look at this one, this is committee of 12. Be chosen from a group of 21 politicians. And this is committee of 12. Be chosen from a group of 16 Republicans and 5 Democrats. It's still the same combination. Okay? They didn't tell us in how many ways can a president, a vice president, and a secretary be chosen from a group of 16 Republicans and 5 Democrats. They did not ask us that. If they had asked us that, then it would be permutation. But they didn't specify, they didn't list it like what order. So it could be anybody, provided it's a committee of 12 people. Now, this is still 21 come 12. All you need to do is to add up the people. This is like saying 12, committee of 12 from 21 people, 21 politicians. Okay, it's still a case of combination. 21 come 12, which still gives us the same answer as our answer in question 8. Question 10. In how many different ways can a committee of 12 Republicans and 2 Democrats be chosen from a group of 16 Republicans and 5 Democrats? This is still a case of combination because they didn't go into specifics what positions they had to choose. They just said 12 Republicans and 2 Democrats from a group of 16 Republicans and 5 Democrats. Now, in this case, in this particular case, we have to, the number of ways will be, we have to, match similar items. We have to match Republican with Republican, and we have to match Democrat with Democrat. So the number of ways will be 16 come 12 because you're choosing 12 Republicans from 16 Republicans. And is the times. And means times. Okay, times. And 5 come 2 because you're choosing 2 Democrats from 5 Republicans. If we do this with our calculator, when we come here, 4 factorials times 12 factorials equal to this. Cancel memory, put it in as new memory. Then we now do 16 factorials divided by memory recall, and that is 1820. Okay, we now do the next one. 3 factorials times 2 factorials is equal to 12. Change memory, put 12. Then 5 factorials divided by recall memory is 10. So when you multiply that, you have 18200 ways. Okay. Question 11. In how many different ways can a committee of 12 Republicans and 2 Democrats be chosen from a group of 21 prospective candidates? Please, I want you to be observing the differences of these questions. You know, this is 12 Republicans, 2 Democrats, chosen from 16 Republicans, 5 Democrats. So, looks straightforward, right? All right. Now, but what if they now said 12 Republicans, 2 Democrats be chosen from a group of 21 prospective candidates? So that means we have 2 methods here. Okay, I would like to show you the methods. The first method, what we can do first is we can choose 12 Republicans from the 21 people, and what is remaining, 21 minus 12 is what? Is 9. Then you can now choose 2 Democrats from the remaining 9 people. That's what you can do first. Okay, you can choose 12 Republicans from 21 people first, and once you do that, you only have 9 people remaining. Then you can now choose 2 Democrats from the 9 people remaining. When you do that, you have this. Okay, so if we do that with a calculator, we have 9 factorials times 12 factorials equal to this. Remove memory, change memory, n plus. Then you now do 21 factorials divided by memory recall, and that is this, 293930. Then the next one, 7 factorials times 2 factorials equal to this. Then cancel memory, put in new memory. Then you now do 9 factorials divided by memory recall, and that is 36. So it gives you this. So that is one way you can do it. Another way to do this is this. You can choose the 2 Democrats from 21 people, okay? And when you do that, then you now choose the remaining 12. Now, if you do that, 2 people from 21, you are left with 19. So once you do that, you can now select the 12 Republicans from the 19 people remaining. And it's going to give you the same thing. That's the nice thing about it. Yeah. You can first of all choose 2 Democrats from 21 people. Then you only have 19 remaining when you've done that. And then you now select the 12 Republicans from the 19 remaining. And when you do that, you now have this. Okay. So I think we shall go back to the presentation, because I've showed you how you can use the memory in your calculator. So we can kind of now finish this presentation. Let's go back to the presentation. And you, of course, this is the case of combination. And if we kind of will have to write this, since we are now back in presentation, we will write the combination formula. N comp R is what? And we did this in part 1 anyway. N factorial over n minus R factorial times R factorial. Okay, so we have showed you know, we have used the calculator, how you can use the calculator to get that. Okay. Now, question 12. How many different signals can be made by hoisting 3 yellow flags, 4 green flags, and 2 red flags on a ship's mast at the same time? So if we look at this, this is a case of permutation but with duplicates. The duplicates are 3, yellow has 3 duplicates, green has 4 duplicates, and red has 2 duplicates. Okay, so the number of ways will be, you know how many flags, 3 plus 4, 7 plus 2, 9, 9 factorial over the number of duplicates. Yellow has 3 duplicates, green has 4 duplicates, red has 2 duplicates. And when you do that, you now get 1260 ways. And it's the same thing if you're using this, if you want to do this on the calculator, it's still the same way that you do it. The same way. The same way. Let me kind of show you this, because some folks might say, well, you've been doing two things at the denominator. So let me show you. It's still the same thing you could do. Let's remove this memory. Do 3 factorial times 4 factorial times 2 factorial equal to this. Put m plus, put it in memory, then do 9 factorial divided by memory recall. That gives you this 1260 ways. Okay. Question 13. Gold Star Realty received 12 inquiries from prospective home buyers. In how many ways? In how many ways? I just put ways here. Sorry about that. In how many ways can the inquiries be directed to any 3 of the firm's real estate agents if each agent handles 4 inquiries? So you have 3 agents handling 4 inquiries. Each agent handles 4 inquiries. So this is also a case of permutation with duplicates. Yeah. You have 12 inquiries, and each agent handles 4 inquiries. So the duplicates are, the first agent handles 4, that has 4 duplicates, 4 inquiries. Second agent, 4 duplicates. Third agent, 4 duplicates. So you now get 34,650 ways. Question 14. Samdom City employs 15 police officers, 7 of which patrol in cars, of course, and give tickets. Hey, please, cops, don't blame me. But, you know, a lot of folks say that you guys specialize in giving tickets. Now, 6 of which patrol in bikes and give tickets too, and then 2 of which do station duties. I guess those ones don't give tickets. How many different job configurations are there? Okay. What will you call this? Will you call it permutation or combination? It's still permutation of duplicates. Okay. You have 15 factorial over 7 cars tickets, 6 factorial bikes tickets, 2 factorial station duties. So when you do that, you now have 180,180 ways. This is still permutation of duplicates. So if you see questions like that, then you know that they are permutations with duplicates. Permutation of duplicates, or permutation with repetition. Question 15. Mr. C usually gives 20 questions, which is what I do, covering all the sections of a topic. His students must answer only 10 correctly, which includes a minimum number of questions from each section. Okay, if you answer all 20 and get 10 right, that is what I need. You answer 20, get 15 right, I only need 10. 10 must be answered correctly. And that includes minimum number of questions from each section. Assume they must answer only 2 questions from 5 questions in each section asked. How many ways can they answer the 10 questions? Okay, I know this is a kind of long word problem, and some students just read it and, you know, they don't understand it. They get confused right away. Okay, let's look at this now, okay? 20 questions to answer 10. Correct, okay? Now, but if the student must answer, because these questions are broken down in sections, so if they must answer 2 questions from 5 questions that are in this section, okay, I didn't say the number of sections asked so that I don't put a number there to confuse you more. So in this case, you know, 2 from 5 must, okay, remember it must include minimum number of questions in each section. So 2 questions from 5 questions must from each section. Okay, so if the student must answer 2 out of 5, so it's 5 come 2 times what is now remaining. What is remaining? It will be 15 come 8, because if 5, but I asked 20, so 20 minus 5 is 15. Then the student has answered 2, but must answer 8 because to make it up to 10. Okay, answer 2, so but must answer 10. So 10 minus 2 will be 8. So this will be 5 come 2 times 15 come 8. This is a case of combination. Okay, so it will be 5 come 2 times 15 come 8. And when you do that, you now have 64,350 ways. Got it? Question 16. A CIS major must select 3 of 4 mathematics courses. Okay, this is still combination. It is without order. Okay, 2 of 4 business courses, 5 of 9 elective courses, and either 1 of 5 history or 1 of 3 social science courses. Okay, this is the bone of contention here, or the keyword here. Okay, and either 1 of 5 this or 1 of 3 this. So you have that it must select 3 of 4, so which is 4 come 3, times 2 of 4, which is 4 come 2, times 5 of 9, which is 9 come 5. Then and is still times, okay, times either 1 of 5, either, okay, 1 of 5, or is plus, and times or plus. Okay, so the student, you now see when they say either, so it could be 1 of 5, which is 5 come 1, or plus 1 of 3, which is 3 come 1. That's the way it is. So it's a case of combination. So you have 4 come 3 times 4 come 2 times 9 come 5 times, and is this times here. Okay, this times here is this and here, because this is what the student must select: 3 of 4 mathematics courses, and 2 of 4 business courses, and 5 of 9 elective courses. So that's why you see all these times. Then either 1 of 5 history courses, which is 5 come 1, or 3 come 1. Yeah, please, I'm sorry again, this should be plus. You see I put plus here. So let me go and change it right away. Keep. So this is a plus here. Okay. Thank you for following me on this. So that all is the plus. Yeah. So you now do it, and you, of course, you do your PEMDAS. 5 plus 3 is 8. So you multiply everything. That gives you 24,192 ways. Yeah, you see, it's good doing this right here so that, you know, I will fix my mistakes before I upload it on my website. Question 17. 15 applicants applied for 4 open jobs in a company. How many ways can the job be filled if no preference is given to any applicant? Okay. It's just what? 15 come 4. There's no preference. So 15 come 4. Okay. 15 come 4. 1,365 ways. Just the 15 people apply, 4 positions will be filled, and any of the 15 can fill the position. So it's 15 combination 4. Okay, but what if 15 people applied and there is somebody that must be given the job, one job? Okay, this is 4 jobs, and out of that 15, you know, you have one of them that has the high clout, son of the president or vice president or senator. Hey, you must give this guy this job. Okay, that means one person has one job already, so one person is out. Okay, so that means you now have 14 people competing for 3 jobs. See that? And you know what happens in this world? You know, they will just tell you, hey, especially in Nigeria where you have a lot of corruption, when you have people apply, okay, those on top will say, hey, make sure you put this person, make sure you put this person, make sure you put this person. A lot of corruption in Nigeria. That is why the people are suffering. That is this case here. So when you have one person, okay, has a phone call, you must give this person this job. So one person has got the job in one way. So the next, you now have only you have 14 people competing for 3 jobs. So this will be one way. When the one person gets the job, that's one way, times then 14 combination 3, and it will give you 364 ways. Question 19. 15 applicants applied for the 4 jobs, okay? And now guess what? In this case, it includes 9 men and 6 women. Man, guess what? Okay, if one woman must be given a job and you have 4 jobs, okay, you can have at least one. Means what? At least one means more than or equal to 1, greater than or equal to 1. So if I say, please give me at least $20, that means you could give me $20, you could give me $21, you could give me $22, you could give me $23. Okay, so when you have at least one woman must be given a job, that means it could be one woman getting the job out of the 4 jobs, or it could be 2 women getting, you know, 2 jobs out of the 4 jobs, or it could be 3 women getting, you know, 3 jobs out of the 4 jobs, or it could be 4 women getting the entire 4 jobs. Now, when you have this, you have how many conditions now? How many situations do you have here? It could be one woman getting the job, and if one woman gets the job, that means 3 men will get. If one woman gets one job, that means 3 men will now get the 3 other jobs. Okay, so that means at least 6 come 1. Okay, if one woman gets the job, it will be 1 woman out of 6 women, so it will be 6 come 1 times. That means 3 men will get the 3 other jobs, which is 9 come 3. Or that all becomes plus. Or it could be 2 women getting 2 jobs, which will be 6 come 2, and which is times, and 2 men getting 2 other jobs, with the 2 other jobs, which will be 9 come 2. Or it could be 3 women getting 3 jobs, which will be 6 come 3, and 1 man, because if 3 women gets it, then 1 man will now get the other job. 1 man getting the remaining job, which will be 9 come 1. Or it could be, well, 4 women now getting the 4 jobs, and then no man getting any job then. Okay, so these are the cases that we shall consider here. Okay, it could be 6 come 1 times 9 come 3, or it could be 6 come 2 times 9 come 2, or it could be 6 come 3 times 9 come 1, or it could be 6 come 4 times 9 come 0. Okay, if they say that at least 1 woman must be given a job. So if you now do that, you have to do it carefully. Okay, you will get 1,239 ways. Does it make sense? Please tell me whether it does or does not. Now, question 20. A state motor vehicle department requires learners to pass a reading test. The test consists of 20 true or false questions. At least 18 must be answered correctly to qualify for a permit. In how many ways can a learner qualify for a permit? So 18 must be answered correctly. You know, in some tests, you see these cases like, you know, in some tests or assignments, you know, they say you must, this is the proficiency score. You must achieve this, you must be, you know, you must achieve this proficiency before you are given a learning permit. I mean, before you're given a permit. So, which, you know, it could be driver's permit, okay? And of course, 18 out of 20, if you must pass 18 out of 20, that means you must have a 90% score, at least 90%, in order to qualify for the permit. So the way you do this is this, okay? You could pass 18, you will qualify for the permit, or you could pass 19, or you could pass all 20, okay? So this is a case of combination. You could pass 18 out of 20. In that case, that is 20 come 18. Or, which is plus, you could pass 19 out of 20. In that case, which is 20 come 19. Or you could pass the whole 20, which shows you're very smart, right? Which is 20 come 20. Okay? And then you add it up. Gives you 211 ways. 211 ways. Okay, these are the references. Thank you for listening to this presentation. I hope you understood what we talked about. And please watch out for other videos. And you have a great day.